So today we'll be talking about something really a bit insane, to be honest, because I think like since I kind of cursed the day when I came across your content, because until then I've been living quite a good life, to be honest. And usually you have stories like if you find out about things like 9/11 or I don't know, all sorts of conspiracy theories, you're grateful that you find out, it's a good information, but you can still, nothing really changes. But about this specific thing, it's life changing. It's basically going to change how you're going to live your life, big life decisions, everything is just going to change. So before we go into that, I think we're going to go little by little so that it's easy to understand. It's not like too much all at once. So today, just to get started, we'll be talking about cataclysms that happen sort of naturally. Um, but before we go into that, I want to know how did you find out? How old were you when you found out? And how did your life change when you found out about this?
Well, I should have figured it out from some dreams I had as a child, but I honestly didn't figure it out until about 7 or 8 years ago. And the majority of the last 7 or 8 years was actually proving that this is what happened. I thought there was enough evidence to say, yep, this is what it is. But that's not how science works. It's not, oh, okay, I'm starting to lean this way. You need to conclusively be able to prove it to everybody else who may be skeptical or suspicious of your hypothesis. So it took probably the majority of my 30s, I would say, to actually prove this. And what it took was doing what scientists don't do anymore. Um, they don't take a step back and look across multiple different fields of science. It's a good thing that we have very focused specialization in science. That's where a lot of the new inventions come from. But the problem is that's where everybody is now, and nobody takes a step back and looks and sees what's happening there, what's happening there. Can we connect these two things? Is there a relationship between them? The people doing the actual science today don't have the time or the focus to spread elsewhere. And so I sort of stepped into that Renaissance thinking, which turns out is just absent from the scientific world right now.
Okay, wait, so you had childhood dreams? Who has childhood dreams about things like this? Can you tell more about that?
I would be on a beach and there would be something black. I couldn't see lines or a form or whatever, just something black over top of me. And it lifted me up as giant waves were coming. And as the waves were passing, they were just high enough to tickle the bottom of my foot as they went underneath me. And then this thing turned me around so I could watch the waves hitting the land. And I'd say this happened 20, 30 times as a kid. It was very different from most of my dreams. But at the same time, you're a kid, you don't even know what the heck this is. You don't know what a tidal wave is. You don't know what a tsunami is. And so there wasn't a whole lot I could go on. Luckily, I remembered it from
20, 30 times, that's a lot. Like, I don't remember any dream that I had as a child. So, wow. Okay. So, it's kind of like what is it called? In English, you say calling. It's like, so.
I do feel like this is a calling.
Mm,
Who I am and the education I received, it is literally perfect for what I do. I can't imagine it being any better. Um, I'm a speed reader, which really helps. I have a mild form of hyperthymesia, which is that memory disease where you remember pretty much everything. I have the mild version, so I remember things that impact me, not every last little thing that ever happens to me. Turns out I think this is probably more useful. I'd go nuts if I could remember every last little thing that ever happened to me. Um, I came up against a climate zealot in college as a professor, and he sort of damaged me intellectually enough to be questioning authority figures in academics, which is also very necessary if you're hoping to break any kind of mold whatsoever. And because of that one event, also, I kept the science, but I also looked into economics and law, sociology, psychology, and you actually need all of those to fully understand what's happening right now. Yes, it is mostly based in science, but when you can pull together culture, the economy, even things like religion, this story actually starts to make a lot more sense than it does if you just try to stick to the science.
Right. And so how did it, so when you finally found out that it's probably going to happen in your lifetime, how did it change you?
I'm not sure it did. There's
Really?
there has been there has been this feeling of not wanting to dive in too deep throughout most of my life up till finding this out. You know, I went to university, I went to graduate school. I had a couple of jobs afterwards, but I kept myself on the periphery, being easily able to remove myself. And it was because I never really felt like it was what I was supposed to be doing. The very first day I got into this, I knew for a fact this is what I would be doing the rest of my life. I felt it. And I didn't know I would feel that way when I dove in. I don't know what made me dive in on this one when I really didn't do that sort of thing. I participated, but I didn't dive in. I don't know why I did with this, but I knew I loved it instantly.
Right. Okay. So then maybe we could where would be the best place? Because a lot of people are not very scientific and it can be too overwhelming, right? So maybe we could just like slowly start off.
Well,
I'm
here's a
thinking,
go
yeah.
ahead. If you have a good idea of where to start, you know your audience better than I do.
Tell me, tell me.
The mammoths. The mammoths are a great place to start
All
because
right.
everybody has heard about the mammoths they found frozen in the Arctic, and they were frozen so quickly the food in their mouth and their stomach didn't even digest. It just froze too quickly. Everybody asks the wrong question. And the wrong question is, how do you freeze a mammoth that fast? Wrong question. Bad thinking. The real question is, what were they eating? Because they dug those things out of 20 feet of ice in just the past couple of decades. They were frozen in the glacial cycle when it was 10, 20, 30 degrees colder. If they had to dig them out of 20 feet of ice now, what was it like during the glacial cycle? 10, 20, 30 degrees colder. There wasn't anything for them to eat. Those creatures needed to eat well over 1,000 pounds of vegetation every single day. What were they doing there? And the answer is they weren't there. They were somewhere closer to the equator, and then Earth tilted 90 degrees, and they found themselves at the polar region and froze instantly. That's what happened to the mammoths. And if you think about it, they had to dig them out of that much ice now, and it was way colder when they froze. The only explanation is that part of the world was not up at the polar region back then. It was down closer to the equator. And so that's an example. Everybody's heard of these mammoths.
Yeah. Is it
Nobody has
true that
ever
in
thought
the
about it this
States,
way.
is it true that in the States that maybe it was a joke, but I thought it was true that you could order in a restaurant like a bison? Is that true?
You can order bison, yeah,
No,
but
but
not
the
mammoth.
frozen one from
No,
South.
you
No?
get
Oh,
mammoth.
okay. Sorry. I thought it was a joke. Okay.
That would
Okay.
be a heck of a thing. I might try that though if you could. I
Okay.
do. I did hear that they were able to thaw the meat and feed it to their pack dogs, and their pack dogs loved it. So that
Right.
that's all I've heard about actually ordering or eating any of the meat.
Okay. So then we also have, I think that there's been evidence that there were wolves as well, buffoons, and all sorts of other animals who had in their stomach food that has been shock frozen. And I think it takes maybe like a couple of hours for the food to be digested. And if it's in the digestive system, it means that it was pretty quick. And obviously, they cannot fly, they cannot travel. So that's a good explanation.
Right.
And can you also talk about like there are so many um, indications, right? It seems like everything is indicating to it. If you like look archaeological, ancient archaeological diggings.
Absolutely. I mean, even Einstein was convinced. He died trying to figure out mathematically how you get the Earth to do this. He had already figured out, yes, it does turn 90 degrees. The Earth does turn over. He died trying to figure out how that happens. He didn't figure it out. He also never looked at the Earth's magnetic field, never looked at the sun, never looked at any kind of external or large scale force like that, which is where we are today. But he knew it. All of the catastrophists throughout history have known it. Some of the bigger names who wrote more important books who really kind of got us to where we are today over the last several centuries. And there's also more modern scientific evidence. They dug out a bunch of trees that apparently were died and were buried about 12,000 years ago. They don't have any rings, and they're in Scandinavia, which is Finland, Sweden, and Norway. The only place in the world that doesn't have tree rings is the equator. The tree rings are actually the seasons. That's what you're seeing. You're seeing the growth and then the halting of growth in winter, and then the growth and then the halting of that doesn't happen at the equator. They don't have rings like that. So what are all of these trees in Norway, Sweden, and Finland from about 12,000 years ago doing with no rings? Maybe they weren't way up there. They were down closer to the equator.
Wow, so they survived the whole thing when they
No,
moved.
no, they died and they got buried.
Oh, okay, okay, okay,
So basically, something happened and a bunch of mud covered up these trees. They
okay.
fossilized. They didn't have a chance to decay. They were basically locked in mud. Most of the biological stuff from that long ago, it's either going to be decayed or it's going to be, it will have broken apart, something like that. It's, most trees, when they fall over, don't end up becoming petrified wood. Most of them decay. They need to be locked in mud or something else and sort of preserved there. So we don't have a ton of evidence like this from all over the world because most of it decays. It's just they found these ones that were locked way up there in Norway, Sweden, and Finland, but they don't have any tree rings, which can only happen at the equator. There are other scientific points that we can look at. So, for example, in the late 1940s, the U.S. military went up to the Arctic. Now, they went up there to learn how to deal with the polar region in case Russia came over the top. Didn't end up happening. But while they were up there, they were doing all kinds of tests, and some of those tests included digging down. And when they dug down through the ice, the top layer, it's what they expected. But then there was a layer right underneath it, and it was tropical fossils, and then more polar fossils and more tropical. And it was like it was ping-ponging back and forth between being at the polar region where it is now and down near closer to the equator. And all of these different lines of evidence, they're telling the same story that the Earth goes like this. It does a 90-degree tilt. And because without that, you can't explain some of the things that are found. You can't explain layers in the Arctic that are tropical fossils. You can't explain trees with no tree rings in Scandinavia. And you certainly can't explain what the mammoths were even doing up there in the middle of a glacial cycle when there's nothing to eat at all. So this is sort of the big thing, that the Earth really does this. And
Yeah.
of course, we sort of jumped right to the scariest aspect of this entire event, but it's also one that people can identify with. Everybody knows what a tree ring is. Everybody's heard of the mammoths. And so this is actually, even though it's kind of like the finish line, you know, from a purely scientific perspective, this would be one of the last things you talk about. But it's the thing that most people can actually get their head around because they have experience with this information already.
Yeah. For me, it was the the books, the Bible, Quran, all the scriptures, ancient tablets, all of them seem to be talking about this event. And
Absolutely.
yeah, I grew up as a Muslim. So as I think I was 7 or 8 years old, and as a little girl, we used to hear a lot from like grandmothers and aunties. They would be all, talking as part of the teachings. And I used to be scared of it because I had no idea, but I knew in our language it was called qiyamat, which meant that's it, like that ends. And the features were, I don't know why, but I remember that it was supposed to happen on a Friday, and the sun was gonna um, ascend from. I actually, it's so stupid, but I didn't know that we the Earth is spherical. As a 7 year old, I grew up, I guess, shielded. I all I knew is sun ascends from somewhere, and I knew that the sun is gonna ascend from the opposite direction. So that's another thing, and that it was gonna be black. So I actually had fear of waking up one Friday and that seeing the sun black. But then obviously years later, I forgot about it, and I didn't even have that fear anymore. It's just it was sort of like a part of the religious teachings. I only remembered it when I think heard you saying in one of the live streams that the sun is gonna be, I think, dark or something like that. And then it hit me, oh my God, is it the same thing that I heard as a, part of the religious studies?
Yeah, well, it's interesting. I remembered that from a kid because the black sun is in the Bible too. And but I kind of forgot about it and I didn't tie it in until I was trying to look and see, okay, we know what is happening in our solar system right now. When this progresses further from a chemistry and a physics perspective, what is going to happen to the sun when this hits its peak? We can talk about what this is in just a minute. But the fact is, processes on the surface of the sun start to short circuit. It loses its brightness and its luminosity, and it starts to dim to a red and then a black. And then there's also dust that is covering the sun because it's not pushing out as strongly with its ultraviolet rays and its solar wind. And so we basically have this sun turning black as sackcloth for a couple of days while this disaster is happening. And I say while it's happening because at that peak, when the sun can be affected so tremendously, you better be sure the earth is going to be affected very tremendously as well by those same forces. And so, yeah, it wasn't actually until I did it from a scientific perspective and I said, okay, from a physics and chemistry perspective, the sun should be doing this. And then it hit me like, wait a minute. How would they know that back then when they wrote this book? And then I found it's in the Quran, it's in the Bhagavad Gita, it is in all of the Vedic stories, it's everywhere in every single story from all over the world between cultures that never talked to each other. Some of them rose and fall before other ones even came into being. How did they all know what was going to happen thousands of years ago? And it starts to make you realize, wow, the only way they could have known is if they watched it happen already. And then you remember, okay, wait a minute. I didn't get to this science and chemistry of the sun thing without taking the first steps. And you go back and you realize, wait a minute, this happens on a cycle over and over and over again. That's why we have stories about it. In India, they have stories from the last 5 cycles. That's insane to me. The Indian culture has preserved the last 5 destructions of the earth, not like blown to a billion pieces, but cataclysms that have hit the planet and then the rebirth into a new age. And so you start looking, okay, what can we track throughout time to see when these things happen? And the best thing to do is track volcanoes, climate, and Earth's magnetic field. This magnetic cocoon that protects us from all the scary stuff in space, like solar flares and supernova and gamma ray bursts and things like that. And you realize there are these cycles to that as well. Very, very clear as day. And they can find these events going back hundreds of thousands of years. In fact, they can even spot some hints of these things back in the Jurassic and Triassic period, millions of years ago. But more relevant to what we're talking about, the last couple show up very, very cleanly in the data. Now, as you listen to these dates, and as your viewers listen to these dates, I hope that they can track this in their heads. It happened 36,000 years ago, 30,000 years ago, 24,000 years ago, 18,000 years ago, 12,000 years ago, 6,000 years ago, and it's happening again right now. So without the 1,000 years ago part, that was 36, 30, 24, 18, 12, 6, 0. It happens about every 6,000 years that this goes. The last one was 6,000 years ago. The one before that, 12,000 years ago. We are perfectly due in time for the next one. So then we say, okay, well, what's happening with our climate and what's happening with Earth's magnetic field? The climate, well, okay, they might be blaming us, but it's not our fault. Believe me, a couple of millionths of atmospheric chemistry is not doing all of that out there. I promise you. And at the same time, Earth's magnetic field has already begun to shift. We are losing the structure and the strength of Earth's magnetic field, which is exactly what we see every single one of these events. There's climate chaos and chaos with Earth's magnetic field. We're perfectly due in time in this cycle, and we're seeing it unfold before our eyes. And so the question then becomes, okay, let's go with a hypothetical. Let's say this is not a coincidence. Let's say it's not a coincidence that we're due in time and we're seeing everything to suggest, yeah, we're due in time and it's happening right now. The question then becomes, how bad will this get? What is going to happen next? When does this hit its peak and we actually get the catastrophe? Because we're on the road to catastrophe right now. Things are looking rough, but we're not there yet. And that should be obvious. The world is still spinning. We're talking on the internet right now. The global economy hasn't collapsed, things like that. So we're on the road there. But the question is, how bad and when? That's the important part for everybody listening and for everybody living out here in the world today.
Yeah. So maybe like we could get started with how and what is going to happen, right? So, for example, this book starts with showing the image of the Earth's molten layer and the core. So maybe we could start from there.
Well, just out of curiosity, is that the 1960s, 1970s, 1980s, or 1992 or 93 version?
Oh, I have no clue.
He wrote 4 versions of the book. Which one is? If you look on the inside, the inside cover, it'll give you a publishing date. He did it in the 60s, 70s, 80s, and then like 92, 93, 94, somewhere in
there. This is the problem. This book very much looks like it was published on Amazon, like Amazon self-publishing, and it has nothing, no information. So when I bought it, I actually thought it's going to be 53 pages because it was, I think, first CIA released the first 53 pages, but turns out it's pretty much looks like the full book, but it has I have no idea. It's
So
blank.
how much of this version have you read?
All of it.
Okay,
253
so
pages.
he doesn't include the sun and the galaxy until the very last version, the one from the 90s. So if in somewhere in here he's talking about it's actually the sun and the galaxy that is doing this to our entire solar system, that's the one from the 1990s.
Oh, okay. It
If
talks about the null zone. The
the
null zone.
that's the galactic current sheet. So this is the
Mhm.
one from like 1993 or so, approximately. This is his best one. He does make a couple of little mistakes, but to be honest, it was because he didn't have the right information that we have now. It's kind of like if you tell somebody to screw in a screw, but you just give them a hammer, it's not going to look the way it's supposed to look. You know what I mean? So he didn't have the right tools or the right information. But all right, so getting back to your question about the molten layer, the core.
Yes. Let's start there.
Okay. Well, what is the question there?
So the question is, why is this a problem? Why is this going to be part of the problem in the cataclysm?
So I think it's most people can imagine why climate chaos is a problem. Most people can probably imagine why, if there's a major uptick in volcanoes all over the world, that could be a problem. Most people don't understand why losing the magnetic field is a big problem. The first reason is it's what causes the climate chaos and the volcanic chaos. Why? Earth's magnetic field, remember what I told you it does? It protects our planet from dangerous radiation that comes from space. During this shift, which has begun already, we are starting to lose that protection. That means more electromagnetic radiation from space is making it into the Earth system. Some of this is deposited into the atmosphere. Some of this makes it all the way down into the crust and the mantle. At its peak, this is what will trigger the volcanoes. It's already begun to trigger the climate chaos, and it's only going to get worse. And it doesn't matter what kind of car you drive or if we stop cows from farting or anything like that. It's going to happen, and there's no stopping it. But while that extra radiation is causing climate chaos and causing volcanoes, which, by the way, also causes a lot of cracking at the fault lines and earthquakes, that radiation is being deposited to where we live. There's a very good reason they tell you don't go eating plutonium. There's a reason why, if a place is a radiation hazard, you're not allowed in there, because it has dramatic effects on your cells, on your organs, on your DNA. And they're also figuring out it has major effects on your brain too. That's actually something we're seeing in the world today, because they know two main impacts on the human brain when there's an increase in this type of radiation exposure. The first thing that happens is your hippocampus right here, the thing that makes you cognitive, think, smart. It doesn't work as well. The mitochondria have trouble making and using energy, which means you get a little dumber. At the same time, deep inside your brain, I don't even know where to point to, but it's deep in there, is the locus coeruleus, and it gets overexcited. The problem is that's the part of your brain that reacts to emotion, specifically terror, panic, fear, and anxiety. So, as we are already starting to see this extra radiation coming in, already beginning to change the climate, does it seem like the world is getting a little dumber and a little more emotionally unstable and reacting out of fear? I think the answer is yes, and I think that that's very obvious. There's a very good scientific explanation for it. It is another way we know this is happening. And of course, we have the radiation detectors. We can see the data. It's just that it's interesting that we can see how it's affecting the climate. If you're paying attention to culture, politics, social interactions, it's affecting people too. And it's affecting them not only in the way that science would say, but the way that religions say. Now, I happen to know the Bible better than others on this topic. But in Revelation, during this time, they talk about people will turn from God, turn towards sin, become more selfish, become more degenerate, and all these. Does that not seem like the world today? Is the world not throwing up a middle finger at God and tradition and conservative values and other things like that in favor of this degenerate Satanism that we have out there in the world today? This is exactly what's described in these ancient books, just like they somehow described what's going to happen scientifically. And again, you realize, wow, the only way they could know what was going to happen to the sun and what was going to happen to people's psychology, they watched this happen already. They saw it happen. And
Yeah.
somebody who was left alive thought to write it all down or at least tell the story to their children and children after that. And so that's really what we're dealing with without getting too specific. We're
Mm-hmm.
already, it's a cycle. It happens over and over. We are
Yeah.
due in time right now. It's
Mm-hmm.
already happening. We can tell by watching the magnetic field, and we can tell because the things we'd expect, the climate, our psychology, they're changing as well as we would be expecting. Now,
Mm-hmm.
glad you mentioned the null point because this is not something that is just happening to the Earth. I mentioned the sun. It's not just happening to the sun. We have evidence of similar changes on every single planet in the solar system. And we are noticing both dust and magnetic changes in interplanetary space. That's the space in between the planets within our solar system. And that's because what's happening is we are taking a galactic magnetic reversal, a galactic pole shift. That is what is happening to our entire solar system right now. This is what Chan Thomas was describing as the magnetic null zone. The problem is that's not the best way to describe it. What is a magnetic null zone? So let's say, all right, so this is a marker. This is not a magnet, but let's pretend it's a bar magnet, right? You got your North Pole and your South Pole. Well, at some point, if you are testing and measuring the magnetism somewhere around here, you're going to come up with zero, right? Because you're not the north fields, you're not the south fields, you're transitioning between them. And so technically, yes, you have a zero. You don't have northern fields, you don't have southern fields, positive, negative. But if what you're doing is crossing that, going from one to the other, practically, what you're doing is you're going through a magnetic reversal, a pole shift, the moment where a push becomes a pull or a pull becomes a push. That's what's happening to our entire solar system right now. And we know it's happening because, one, we can actually see this rippling sheet in our galaxy. And this was decades after we proved in the lab it had to be there. It's sort of like a math and physics thing. We know it's there even before we can actually see it. But they have now seen it. They've characterized it. They know how long it takes in between every single one. They've even spotted this galactic current sheet, which separates the north and south fields of the galaxy at other galaxies. They've spotted it in Andromeda, Centaurus, several other galaxies. And it's the kind of thing where every star has one of these too. Anything that is spinning, that is electromagnetic, imparts this magnetic reversal on the things spinning around it. In our case, that's the galaxy and our solar system spinning around it, and then the sun and us spinning around the sun. It's as clear as day in a lab. For those who watch my channel, we had Billy actually make one in our plasma lab just to show you, look, that this is all you need to make it. And that's what stars are. That's what galaxies are. And so we've come to a point now where astronomers have recognized this. They know what it is. They know it's there. And they know that This thing has to hit us over and over and over again in a cycle. Different astronomers are noticing these changes on all the other planets that seem to indicate there's something major happening. But those two don't talk to each other. And neither of those two talk to people who study the sun. And neither of those three talk to people who study the earth. They literally have blinders on. They don't talk to each other. I know professors who are considered at the top of their game. They don't know what the guy down the hall in their own department at their university is doing in their building. This guy teaches the same classes he teaches. He has no idea what this guy is working on. Why? Because to make a scientific breakthrough today, you've got to be this. You don't have the ability to do this or do this. You have to be this and only this. And what that means is there's nobody who's taking a step back and looking at what everybody's doing, because you can't be a scientist making breakthroughs and doing that. You don't have the time or the mental energy. So somebody else has to do it. And since they're not talking to each other, I did it for them. Now, I had a lot of help. At this point, there's over 100 professors, NASA scientists, scientists at NOAA, the USGS, even a couple of Europeans from the ESA have joined in now. And they have been extremely helpful, especially when I would locate holes in the theory. And one of them's like, there's no hole there. Here's your paper. There it is. Thank you. The picture is now complete. Whether we are looking back through time at paleo, and paleo means historic. So paleomagnetism, paleoclimate, paleovolcanism, modern climate, modern magnetism, modern culture, modern sociology versus the one they told us about in the religious books. Heliophysics of the sun, astrophysics of galaxies, atmospheric dynamics of clouds and jet streams. All of these stories tell the same tale. All of these fields of science are telling the same story. At some point, ignoring that many coincidences becomes your own fault, right? Which is why, even though I am just some guy on the internet, there's over 1 million people across the platforms that listen to me. It's why I've got 100 of the world's best scientists emailing me, asking me questions, because they don't have the ability to do this. They're like this. They're like this. But they took a peek and they saw something else. And so now they're like this at work, and then they come home. Let's email Ben here. Or let's see what's going on here. And
it's
so
sad, but
it is, but at the same time, it's beautiful, because where we are now is where Galileo, Copernicus, Socrates was at one point, where here's the story. It's got no holes. We're just waiting for everybody to figure it out.
yeah, but I don't think a regular person can just figure it out. Everyone just goes to work.
You have to have somebody like me putting them all together and explaining them to you. If it wasn't for the fact that I know meteorology and I know physics, and you wouldn't be able to do it. And the fact that I'm great at math. If it wasn't for the fact that I have hyperthymesia, I wouldn't be able to remember and pull all of these things together. If I was a professor, not only would I be like this, but I would have office hours, tests, or papers to grade, department politics and meetings and crap to deal with. I'm basically cheating. Dr. Brown at Yale told me that a couple of years ago, and it kind of took me back. But he said, Ben, you're cheating. Look at all the stuff we have to do to be in a position to make science happen. You don't have to do any of that. You don't have to read a script. You don't have to worry about offending somebody. You don't have to wear a muzzle. You have all the time in the world. Your memory works better. You're a speed reader.
Mm-hmm.
And so it's a little like cheating, but good thing I did. The good thing that that's what I decided to do with my life, because we would have absolutely no idea. We would still have people online blaming stuff on Nibiru or HARP or whenever, any one of the things that they inserted into our community to make us look stupid.
Yeah.
We would still be there. We would still be
Yeah.
there.
Yeah. I would still be living blissfully. And so let's go back to the crust. So if I understood something wrong, let me know. So from the book, what I understood is there is this the core, and then there is a crust, and then in between there is this layer that is solid, but when we approach the null zone it's going to become liquid, which will allow the crust to shift because now it's liquid. Is it still
So
correct?
that's close. Where things are happening are the where the crust and the mantle meet. So the center of the earth, the core, they say is solid. Obviously, the crust where we're all walking around is solid. But they say in between those is a liquid mantle. That's where the lava is, that comes up in volcanoes. The problem is it's not like a piece of wood sitting on a lake, which can float around and move around. If you got the crust here and the mantle here, where these two meet, it's a partial melt. So picture cooling syrup or molasses. It's
Yeah,
not
like
really
jelly.
it's not really liquid. It's not
Mhm.
really solid, but it's sticky.
Yeah.
It might as well be glue. That's what's in between the crust and the mantle right now. And the problem is when the sun does what the sun is going to do, which is a great solar flash. Yes, it's going to turn red and then black during the magnetic null zone. And what short circuits the luminosity, the brightness, is that lack of magnetic energy. But we're not staying at zero, are we? We're having the reversal. We're coming out of one and going into the other. When that clicks in, the sun wakes back up in an instant and blasts off the shell in a solar, what I call the solar micronova. People call it the great solar flash. There's a lot of different names for it. I choose to be technically accurate within astronomical terminology. But when that hits the Earth, especially with Earth's magnetic field not protecting us like we're used to, that energy, which again, it can go all the way down to the core. But when it gets to in between that crust and mantle, that's a lot of electric current, a lot of resistive heating. It melts that layer. And when
Okay.
it melts that layer completely, then the crust is free to do whatever it wants to do. And it just so happens that we can tell what it wants to do based on where the ice weight is. So if you could unlock the crust today, like that, we already know. We've done the math, we've done the modeling. And when I say we, I mean like real scientists with supercomputers. We know exactly what would happen if you could unlock the crust, how it would turn. The problem is, the question is, how do you do that? That's what Einstein died trying to figure out. The thing is, now we know it's the sun, because now we know even modern day solar storms. I'm willing to bet some of your fans saw the auroras last year, either in May or October. Little thing, I mean, that was a big event compared to normal, but compared to the event I'm talking about, that's tiny. That we detected the electric currents that shot into the mantle from that solar storm. So we know they're making it to where the crust and the mantle meet. They're making it past that. During the biggest of all events from the sun, it melts that layer and then the crust turns over 90 degrees.
So the how does magnetic poles come into play in this?
The magnetic poles are changing because the entire solar system is going through the galactic magnetic reversal. And so our magnetic poles are shifting. So is the sun's. So are Jupiter's. So are Saturn's, Uranus, Neptune, Mars, Venus. They're all shifting right now. It's why we can see the changes on the other planets that we can see. And some of them, Jupiter, Uranus, and the sun itself, we can actually detect its magnetic field changing. So other ones, we have indirect evidence through the atmosphere, like we have here on Earth, because I know this. It's not CO2 doing this here. It's definitely not CO2 doing this on Neptune and on Saturn and on Mars, which all have much worse climate change than we have. It's this magnetic pole shift, which is taking on every single planet and the sun. And it's what's causing the increased radiation that is causing the climate chaos that will eventually cause the volcanoes, that is already causing people to lose their freaking minds. And that's just going to get worse as well. It just so happens that that's only the Earth effects of this. What this whole thing is going to do to the sun also has back effects on the Earth when the sun does what it does. And so there's kind of two ways the Earth is getting hit by this. One, we're getting hit by the overall magnetic reversal, and then the sun is going to hit us as well. Now, Chan Thomas in his book, he describes, he doesn't quite describe it the same way, but again, he was trying to do this without all the right information. In fact, some of the guesses that he did make were absolutely amazing, given what he had to work with.
I think he says that the magnetic poles, they're sort of like pulling, they're drifting off and off and off. And as soon as it becomes, the layer becomes liquidy, it just shifts like quickly because it's been pulling, it's been drifting off and pulling, right?
So that's where I don't necessarily agree with him. And that was a pretty good guess. The problem is, as the magnetic poles move, they don't actually pull anything. It's not actually pulling the Earth.
Really? Okay.
There is a pull right now, but it's from the ice. So basically, imagine if, this is here and it's like this. And you say, why isn't this falling over? It looks like gravity wants to make this fall over. But what you don't know is it's glued to my hand right here. Okay? That's like the crust in the mantle right now. Now, what this tilt is, this is not the magnetic field. This is the ice at the polar region. Here's a physics lesson that everybody should know. When you have an object that is spinning, if there is some point on this spinning object that weighs more than everything else, so let's say it's a plastic ball, but you put a piece of lead tape, up here somewhere. So that's the heaviest point, and you spin it. Eventually, that heaviest thing is going to end up on the equator. Why? The greatest point of weight distribution, the heaviest point, wants to spin at the point of greatest centrifugal force. And for a spinning object, that's the equator.
Oh.
The ice at the polar regions is the heaviest thing. They want to be here. They want to be here right now.
That's why it goes to the...
Okay. And that's why it goes like this, exactly 90 degrees. And then these start to melt. New ice forms at the poles. So for it to do it again, that's why it's exactly 90 degrees every single time.
Interesting, because this is easier for me to understand from my non-science brain, because with magnetic poles, I couldn't really picture it, because he says
it's fun to think about, but then you get into the math and the science, you're like, no, just the magnetic poles aren't going to do this.
Yeah. Okay. Another question that I wanted to ask you is, his explanation was that we circle around this null zone in elliptical manner. So not like a circular, but like we go like elliptically. And that is why his explanation of them, the eras, right? I mean, do we call them era? Like the
eras. So I do know what you're talking about.
Yeah.
He was making an okay guess at that. But the guess is only okay because he's going with the dates of the previous ones. The problem is, since that time, which was now 60 years ago, we've come up with better dates, and it's not staggered. It's not this far and then this far and then this far between on the timeline. It's actually perfect. And so that was one of the things he had to guess about. But his guesses were based on bad information to start with. So, for example, we're not circling around some null zone. The null zone comes outward in all directions from the center of the galaxy, just like it comes out in all directions from the center of the sun. In the solar wind, we get hit by the sun's magnetic reversal of the solar wind every 5 to 10 days. It happens much more rapidly than we orbit around the sun. You know, it takes us a year to go around once. We don't orbit directly at the sun's equator. We kind of go up and then down a little bit and up, about 7 degrees of inclination. But even still, that's over 1 year. So we cross the sun's equator once here and once here, twice in a year. But we get that north versus south swapping in the sun's current sheet every 5 to 10 days. It takes us 250 million years to go around the galaxy. It only takes us 12,000 years to get hit by that galactic magnetic reversal point, the same kind of scaling up. And so it's not something we're circling. No, it's something that is coming out from the center of the galaxy. Now, I can just tell, because we talked about this and the ice, and you're going to have somebody, I promise you, who's wondering, wait a minute, don't we have ice that is millions of years old? How could that be if it comes to the equator and it's moving around? And to that, I say two things. First of all, we have glaciers in the tropics today. Indonesia, South America, Africa. There's glaciers in the tropical zone today. And we are 12,000 years into a hot interglacial period. If 12,000 years of a hot interglacial period didn't melt all the glaciers, then in previous cycles, which the last 8 were all glacial cycles, there's no way the polar ice melts. If this didn't melt all the glaciers in the tropics today, no, the poles aren't going to melt. And so there will be ice left over from millions and millions of years ago. But it's also important to remember, they don't know how to date ice to save their lives. My favorite paper, I think, of the last 2 decades, they used a brand new type of isotope dating in the Himalayan mountains. They wanted to know how old that snow and ice was up there in the Himalayas near Mount Everest. Previous work had said this is more than 500,000 years old. So again, that's older than 500,000 years. This new one said maximum age 17,000 years, meaning it could be much younger. They don't know what they're looking at. There was recently a crater in Australia they thought was 350,000 years old. Now they're saying actually it's less than 200,000 years old. They don't know what they're doing at all. In fact, when it comes to ice, if it's not krypton dating, just ignore it. When it comes to almost anything, if it's carbon dating, ignore it. Oxygen, chlorine, argon, much better isotopes. But the point is, over time, they've gotten better at telling us when these events happened in the past, because they're correcting their mistakes. But as they've done so, it has painted this picture of, okay, wait a minute, now that you've corrected all of this, these things are happening every 6,000 years. When was the last one? 6,000 years ago.
But wait, wasn't it 7,000 years ago? Like in the book, it says the Arctic Ocean era is 7,000, right?
He's wrong. That is what I just explained to you. He had the wrong information. All of that.
Usually they tie this to the Y chromosome bottleneck situation, which was 7,000 years ago.
That was 72,000 years ago.
Not
That's when the
7,000?
bottleneck was. No, that wasn't 7,000. That was 72,000 years ago. But something very different happened at that point. That was when the Toba volcano blew. I mean, there was something like only 40 to 100 reproducing females were left alive on this planet. We came that close.
Yeah.
And of course, that was more than just this. That's when the Shoals star red binary system came right through our solar system and started all of the Nibiru stories. That's where all those are from. They're from 70,000 years ago. Sitchin made up the rest. This whole 3,600-year orbit is completely made up. But a red binary system with several planets came right through our solar system 70,000 years ago. It's called Shoals star, and it's a red binary system, and it appears to have 6 or 7 planets. That was a major event. That was far worse than what I'm talking about. Because here's the thing. What I'm talking about is bad. Life is here after every one of them. Humans have made it through every one of them. Every one of those stories from the Indian subcontinent talks about a week of hell, followed immediately by a golden age. Because what that giant solar flash does, remember I said, oh, it'll touch the mantle, but it'll go all the way to the core. When it does, it'll charge up our magnetic field for another 12,000 years. And that powerful magnetic field is how we get the golden ages of Earth environment. Nice temperatures, calm weather, light rains in the evening, beautiful sun during the day. That's how it happens. The powerful magnetic field is recharged. Our planet has its juice back, and we live in the golden age for a little bit as a reward for surviving the week of hell.
So if that happens every 12,000 years ago, what would be the difference between 6,000 cycles?
Beautiful question. So this thing that causes the magnetic reversal, it's like a wave. All right. So let's say here's where one wave is just hitting me, and here's the next one coming 12,000 years later. Okay. What happens right here in the middle? I'm closer to this one than this one, right? Let's say my head is made of iron and these are magnets. At some point, this one's going to start yanking more than this one because it's closer to it. This is, instead of being pulled this way, we're being attracted to this one. When we hit the midpoint, oh, nope, now we're attracted to this one, waiting for that impact. That's the midpoint. And so 6,000 years ago, it was a medium event. That was when we were here. 12,000 years ago, we actually took the hit. That was bad. 18,000 years ago, right in the middle. 24,000 years ago, last glacial maximum, the coldest moment of the glacial cycle. That was bad. 30,000 years ago, another middle event, moderate. 36,000 years ago, however, the Mono Lake excursion, and that one was very bad. And so we have every 12,000 years, it's really bad. But on the half cycle, 6,000 years in between, there's a more medium level event. Now, medium level event is maybe not the best way to describe it, because the medium level event is what happened to Noah. That's what happened back then.
Wait, so doesn't it mean that then the one that is upcoming is going to be the bad one?
Yeah, this is a bad one. This is what happened 12, 24, 36, 48,000 years ago. Okay, but great. We survived all of those, and we're going to survive this one again.
Okay. Now, walk me through. So this is the day. We are at this. What is going to happen?
The day. What do you mean?
Friday morning, the sun came out from the other side. It's black.
Well, it's not going to be like that.
Okay. How is it going to be?
First thing that's going to happen is over the next several years, we're going to notice the climate's going to get worse and worse. The volcanoes are going to start to go. Basically, imagine that Hunga Tonga eruption from a couple years ago. Imagine one of those every couple of months. The radiation is going to start to get pretty bad. It's going to start affecting airplanes a lot more. this whole thing where we see in society out there, people are getting dumber and more emotionally insane and more degenerate and more turning away from God. You expect a lot more of that. And then one day, the sun's going to turn red. And over that day, it's going to turn black as well. And it's going to be black for about 3 days. At the end of that, the sun is going to click back on. It's going to blast us. It's going to unlock the crust and we will turn. Now, even though the sun has blasted that off, the sun's not going to look totally normal because there's a whole bunch of crap in between us and the sun. That's not only in between us and the sun, but it's been deposited into our atmosphere. It's basically dust. And when we get hit with that, the crust unlocks and goes like this. And then for about a week, the oceans are going crazy. Volcanoes are going crazy. Wind is going crazy. Storms, lightning, hail, all of it. The whole biblical thing. And then it calms and we re-enter. So it's basically a week.
Yeah, just like in the books, in the holy books, I think it's 7 days.
Yeah.
So in the book, it says that the North Pole is going to be where the Indian Bengal Sea, and the South one is going to be where the Chile, South America.
Very close. Very close.
So it's just going to go like this. But why is it going to go like this? Couldn't it be the other way around?
Like I told you, we know where the ice weight is pulling. We know how the ice wants to pull. We can look and see where the ice is now. We know how the Earth.
Because it's already a little bit to the left. It's already going in that direction.
We haven't tilted at all. None of that has happened. But we can look and we can tell that the greatest huge mounds of ice that are basically causing the weight distribution to be off are in Greenland and the part of Antarctica just south of Australia. It just so happens that one of those is right here and one of those is right here. This one wants to come here. This one wants to come here. The only two ice weight points that could do it want to pull the Earth in the exact same way. And that would be, if you wanted to do this, give me 1 second. Take Greenland, and I'm going to do this backwards because you're seeing it. Take Greenland.
Yeah.
Put it at the equator.
Mm-hmm.
When you do that, what's up here and what's down here? What's up there? You're right next to India. And down here, you're close to South America. Now, it's hard to like hit the points exactly when you're doing it like this, but I mean, this is pretty close to what it's going to look like. Planet goes like this. You've got your new north and south poles. Okay, India's upside down.
Mm-hmm, mm-hmm.
So where they're going to be exactly, it's hard to know. But here's something interesting. You take the Earth and you do this, right? Let's do this.
Yeah.
How does he get his wave from the Pacific if the Earth's going like this? No, the wave is coming from the Gulf of Mexico and from the Atlantic. So Chan Thomas did a great job with what he had to work with. But with the pole positions he identifies, which I can tell you are absolutely accurate because that's where the ice wants to pull the planet anyway. That's where the magnetic poles are actually shifting to. So that is correct. The problem is, if you use that tilt in those new pole positions, his wave is impossible. The one from chapter 1 is impossible.
Yeah, he said that you should be on the eastern side of the mountain.
He couldn't conceptualize it like that. Basically, when we look at the waves, they're going opposite directions every time. Now, what he was probably relying on was the fact that 12,000 years ago, the Pacific broke through the Rocky Mountains. It did, and it dumped into the Gulf of Mexico. The problem is the waves are going the opposite direction. So Chan Thomas's first chapter is largely nonsense. That and the fact that it's not a 2-mile high wave and there's not 1,000-mile-an-hour winds. Because I'll tell you what, there's no blade of grass or tree that can survive 1,000-mile-an-hour winds. The entire planet would be dead if anything even remotely close to what he says happened actually did happen. I just took a look at the clock, so this is going to have to be the last story. But it's not a 2-mile high wave. Picture a high tide on steroids that lasts for 12 hours. So picture you're standing there and all of a sudden the waves is touching your toes, but a minute later it's at your knees, and a minute later it's at your belly button, and 5 minutes later, if you're floating in the water, the actual beach you were standing on is 40 feet below you, and that lasts for 12 hours. Is it possible to just float away and survive? Yeah, bet a lot of people did that before. The problem is, if that's your plan, you might want to have something that floats, because if you saw the Japanese tsunami or the Indonesia tsunami from 2004, it's not just water, is it? It's cars, trees, rocks, houses. You might want something a little sturdy. And then after those 12 hours of you basically floating in one direction, everything stops and you start floating back the other way. And that's when you have to get to land as fast as humanly possible, because if you don't, you're going to find yourself out in the middle of the ocean. You just survived the hand of God and the sun attacking our planet, only to die in the middle of the ocean. So there's 1,000 little things to think about when it comes to this, but it's nowhere near as scary as what Chan Thomas says. There can't have been a 2-mile high wave. Nothing would be left. 1,000-mile-an-hour winds, nothing would be left at all. And that the fact that we're having this conversation should give you hope.
Yeah, so that's a good news. Now he mentions that the best place to survive is mountains. Is that true?
There are several cultures that survived the last one. None of them lived by the ocean. They all lived up near mountains or in the mountains, and they all had a way to hide underground. So picture just a couple miles away from me here in Colorado Springs, the cliff dwellings carved into the mountain. Derinkuyu, Cappadocia in Turkey, huge underground cities. These are where people survived. Now, the underground part, really helpful, not absolutely necessary. And something like a cave or a mine can work. Heck, a root cellar could work in theory. You're just trying to get out of the wind, out of the rain, out of the temperature differential, and away from the hail. I mean, all you don't need to be a mile underground. 6 inches of dirt above you, no hail's getting through that. So it's the kind of thing where do not get too scared, because humans survive this every single time. But you need to put some thought into, where do I live? Based on what I showed you, where's the water coming? If I don't have electricity, is it too hot or too cold to live where I am? You know, most of the people who live in Montana, like if you could say everyone in Montana will survive, a year later, 90% of them are going to be dead because of what winter in Montana is like, right? If they don't have society, if they don't have power, there's no gas, no heat. Not many people understand how much firewood you need in a year. And so it's the kind of thing where you have to kind of think, all right, how did the Vikings live? How did people live 5,000 years ago? Because that's what's on our plate. Again, we are getting a restart.
Yeah. So now I'm in Europe, and I remember there's a couple of my friends, we watched your live stream, and somebody actually asked you, what about Europe? And your answer was somewhere else.
Somewhere else.
It's a funny joke that we have here now. It's like, not in Europe. So I used you had a chart. I think it was multiplication of altitude to how far you are from the shore.
Here's that equation.
Yeah.
Elevation in feet plus miles from the ocean. You want that number to be over 5,000. Whatever those two combined are. Elevation in feet, miles from the ocean. Make
But
that number.
there are some places in Europe that like fit under that category. However,
There are. The problem is, I think one of them is very, very close to a high population area. Anything high population, automatic no. Any city, automatic no. Because when there's no food and water, everyone's going to be eating each other. I mean, getting a bullet to the head is about the best option you can hope for, because the other option is somebody eats you in a city. Stay away from any city. That's like number one. And the problem with the other mountains that are far away from the water is, have you seen those places in wintertime? Who is surviving up there without electricity? And so it's like, well, when you look at it like that, you literally just draw a giant X on Europe, the whole thing. And it's hard to get away from that. I have time for maybe one more question. Then I'm going to have to go pick up my children.
Okay, great. So it would be, what is your opinion on the so Dzhanibekov's oscillation hypothesis, where he says it's just going to be like a flip?
You're talking about EDCO, the ethical skeptic.
Yes.
I like it as my second favorite option. I think it's interesting. I think in terms of a missing piece of climate science, he's got it nailed. Did you know that none of the internal heat coming out of the Earth is factored into climate models at all? I mean, simply eliminating it from climate models is a massive error. And so I think he's got a lot going there. Interestingly, he says the tilt is what, 104 degrees? Frankly, 104 versus 90, these things are within the margin of error. And, you know, he and I talk on X all the time. You may have even seen us interacting. He and I agree that 90, 104, this is kind of, it doesn't matter. The issue I have with the whole Earth turning, like starting at the core, is I'm not sure what the trigger for that would be. And I also think that the volcanic activity of that would be absolutely insane. But, you know, it's my second favorite option. I just happen to like the unlocking the crust option because, one, I can do the math. Two, it's way easier to just unlock the crust than to tilt the entire solid Earth over. And three, I know that this solar blast is coming and will do this to the crust. And so, you know,
can you talk about this Carrington event type of a thing that's going to happen before this actually cataclysm?
Yeah, I can. So this is why it's important to start prepping now, because Earth's magnetic field protecting us from all that scary stuff in space. One of the things it's protecting us from is the global solar EMP, the solar kill shot, where basically we get hit with a big blast from the sun. It cooks every wire, every transformer. There's no plants. People's houses are catching on fire. Cars don't work. There's no manufacturing. There's certainly no communications or internet or anything like that. Every satellite is toast in a moment. And we're basically back in the Stone Age at that point. Now, the U.S. government estimates that 90% of all humans would be dead in 6 months. I think it's probably closer to 2 months.
So because how does it what exactly happens so all the electricity will be out?
Every copper wire is going to melt. Any building that has electricity is going to burn down.
Interesting. Okay. Every building that has electricity, every building already has electricity.
Very good.
I cannot imagine any house.
Look, guys, look at her face. Look at her putting it together right now. This is what's going to happen. And the thing is, this is before all of that stuff we were talking about.
Yeah.
Because that's just how strong is the sun firing at us versus how weak is our magnetic field. The sun could do that tomorrow. What happened in May of last year, when half the world saw the northern lights or the southern lights, if that had been about 2 or 3 times stronger, that's it. We're not having this conversation. Good chance we're both dead. We came that close, and our magnetic field is getting weaker and weaker and weaker every single day, leaving us more and more vulnerable every single day. So eventually, yes, the sun is going to turn black. And eventually, yes, it's going to blast us and the earth is going to go like this. Maybe a few tens of millions of humans will be around to see that. It won't be billions, because the sun's going to take out power at some point before that. Could be tomorrow, could be 5 years from now, could be 10 years from now. We don't really know. That's the unpredictable part of this whole thing. It's easy to track Earth's magnetic field. That's going to happen at some point in the 2040s. All that stuff we've been talking about so far, that's about 15, 20 years away. The sun could do what I just described tomorrow. Mm-hmm. And then good luck. Good luck.
Also, the everything that asteroids and meteors are also being like, it's being shielded by the magnetic field, right? Does it also mean there's going to be more?
I don't think it really shields the meteors and the asteroids very much. No, okay. Maybe a little, but because it's a magnet, anything that could be repelled, if it's turned a different way, it would get sucked in. Think about it. It's a magnet. What happens if you got 2 north poles? They push away from each other. Flip this one around, snap. So it doesn't really do that much, and the amount of metal in there isn't that huge anyway. But essentially, what people need to understand is this is a tale as old as time. It's a cycle involving the Earth, the sun, and our galaxy. Humans survive it every single time, but it's very, very rough. We are absolutely going back to the Stone Age in the next 15 or 20 years. And that can be planned for. It's not going to be fun. But if you have any kind of something in here, if you've got children, I think you can find it.